Moment of inertia above of a rod about an axis through its center and perpendicular to its length is ml square by 12. This should be ml square by 12, where m is the mass and l is the length of the rod. The rod is bent in the middle so that the two halves make an angle 60 degree. The moment of inertia of the bent rod about the same axis would be equal to, that is about the same axis as the initial would be equal to. I will take a rod over here. Let us say its length over here is equal to L and the mass over here is equal to M. If I bend it at the center, the rod will look somewhat like this, making an angle 60 degree with each other. Okay, the length will be equal to L by 2 and the mass over here will be equal to M by 2. Similarly, mass over here will be equal to M by 2 and the length over here will be L by 2. Now the axis passes from the same point, that is the axis passes from this point. I will consider this as thin rods, so I will consider both these points as same. Okay, this is the same point. Now if you consider the axis perpendicular to this, perpendicular to the length of the rod, okay, if you consider the axis perpendicular to the length of the rod, it makes an angle 60 degree. Okay, it makes an angle 60 degree. So over here the 60 degree, now over here if I consider the axis, over here the axis is passing from the end of the rod. So the moment of inertia of the first rod will be equal to, at the end, the moment of inertia will be equal to half 1 by 3 m by 2 L by 2 the whole square. This is the moment of inertia of the first rod, and of the second rod also will remain same. Okay, now I have distributed into two rods, okay, in two halves, so it will be equal to I1 plus I2. Along both the rods it will remain same. So the total moment of inertia will be equal to I1 plus I2, which will be equal to 2 times I1, that is 2 times I1 will be equal to 1 by 3 m by 2 into L square divided by 4. So over here 2 and 2 will get cancelled out. It will be equal to ml square divided by 12, which is option number B.